Welcome back to Minecraft. Elfie, Aiko, and Malinka, and me, Fireweaver. Hello.
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 Ahoy.
Cool, so we are back at the alien citadel, and we have a roof. We have like a proper nice steepled roof, and since I turned fraps on for some reason, the top of the steeple disappeared, but never mind. We'll go up and have a proper look. So, cool. So yeah, Aiko and Elfie have been hard at work building this roof. We've got a little platform out so that the alien overlord can look out on his minion troops and be like, wrong, 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 wrong.
That reminds me of someone.
That's what we hear when we're building things.
Yeah.
Yeah. That's totally me. So yeah, that's changed. We're going to be building some stuff on these two roofs as well, but they look great. I think the already the roof design is already making the citadel coming together a bit more. So that's cool.
Much more intimidating.
Yeah, yeah, it's nice. Overlooking the alien wasteland. Which, yeah, so we've left the mob spawner on while we were building and doing stuff and about. We've got what, 44.5 stacks of blaze rods. That's pretty fun.
Pardon?
I think we definitely count as mass murderers now.
Yeah.
Blaze genocide.
Okay, here's something that Elfie made. Elfie, can I take the risk of taking off my armor?
Yeah, you can.
Okay.
Woohoo!
Take it
Strip
off.
it!
Laugh it up, boys and girls. Laugh it up. Right. Let's see. So we built an
Yes, we
arcane levitator. There's actually 4 blocks of arcane levitators underneath, and if we use the stairs, why won't the stairs work? That's weird.
Jump once.
Well, I'm gonna have to jump. Yeah, it's just weird because I thought stairs worked. Oh, never mind. Right, and if we float up, and it takes us into.
Not gonna lie, I'm so tempted to turn the downward one off.
Don't even. And I'm hiding the room on purpose, but we've also got this thanks to a subscriber. God, I've forgotten the name. I'm really sorry, but whoever suggested about the downward arcane levitators, thanks, because they do work fantastically. Look, no armor and no damage. So that's fantastic. I will put my armor back on though, just for now.
You need like a tube on that downward one, which you can set to just go into the blaze spawner, just to puncture.
Nice. The up one
Well,
does
you can make a portal
bit
in
of
the
damage
ground.
to you just because it's perhaps going a bit too high, but yeah, I'm not sure about that, fixing that yet. Maybe I'll work something out. But we've made ourselves a Nexus. We've talked about having a Nexus in here for ages. And this episode is going to be split into 2 parts. One for the average viewer who's just going to enjoy what we're building here. And the second half of this, the average viewer could probably log off and go, "Nah, I'm done now." And anyone who's like into programming and into like the very technical side, they can hang around and find out exactly how this Nexus works. So, Malinka, this is your baby. Do you want to give us a little starter on this?
Okay. Well, as most people can see, if Fire has his view over there, we've got a big ass monitor over here with 5 lines with text. Basically, we've got a Nexus with 5 locations at the moment. The main tripod, the IC2 tripod, which is currently highlighted in blue because the portal is heading that way, our biodome, the engine room, and of course the Thaumcraft pod, or better known as the Thaum pod.
Cool.
It's quite simple.
Shall I right click and choose one?
Oh yeah.
Alright, let's
Where do we wanna go?
To the engine room. Malinka. We've got it's working now. Good.
I think it's because you've got something in your hand, but I'm not sure.
It was corn on the cob, but I thought corn on the cob would work as a pointer. But anyway.
Do you use corn on the cob when you're playing Minecraft? Like just point at the screen and go, eh, eh.
Yeah, to play touchscreen, yeah. nom nom. Anyway, so if we now go through the Nexus portal here, and it will take us indeed to the engine room. And we've actually placed a portal so we can come back. So I'll come back now. And just to prove that we're not cheating the system or anything, I'm going to select a different one. I know you just changed it to the main pod, but I'm actually going to change it to the Formcraft pod. If I can
Remove the damn corn cob.
Yeah, it should work. There we go. Whatever. There's Form pod. Apparently corn doesn't work as a selecting tool. And if we go through in here now, this is now taking us to the Formcraft room. And again, I've got a portal to lead us back out again. So in each of these locations, absolutely work. It's fantastic. Do you want to explain like the very basics of everything then, Linker? Like
Yep.
the route through.
The basics is we've got one computer here in the back that we can show off. That's connected with a wireless signal towards a turtle behind the portal. And there is a bit of a mechanics that might be interesting for everyone, because at the moment there's a really weird bug in Mystcraft. If you try to use a turtle to remove a book from a receptacle with the turtle.suck command, you'll crash your server. Not just a little bit, it'll die definitely. So we thought up a workaround. Turtle above the receptacle to drop down the book, and one transposer to damn, I fell. One transposer to remove the book and move it back into the turtle, with a redstone signal to the right of it coming from the turtle as a signal to remove it when needed.
Yeah.
Quite simple, but it works.
Something we discussed, isn't it, a few weeks ago when we talked about the Nexus, how to get around the crashing bug and to get it to send a signal out. Yeah. And you can see in each slot in the turtle there's different linking books to different places in the overworld. And each slot I think represents, you know, where when the computer's told which button is pushed, it says, right, now grab it from, you know, slot 3 or whatever.
Slot number 3 or whatever.
Yeah.
And you can also see in the logging that every time we change the destination, it does log it back here.
Yeah. Cool. I think you were going to say you're going to put this script for running these things on Pastebin, aren't you? So I'll link in the description.
I am going to try, yeah.
Yeah, so there'll be a link in the description if you want to steal our code. And if I open up the computer down here, do you want to show the basics if someone else was going to use it?
Of course. Let's terminate this one. Typo.
Nice.
And here, can you see it, Fire?
Yeah, the destination list, yep.
Yep. In this destination list is basically the list that is, well, your destinations. Above here we've got max line. Max line is based on a 3x3 monitor. You've got 6 lines on the first monitor, 7 on then, and 6 on the last one because of the corners on a monitor.
Yeah.
So basically you can have at most 19 destinations visual, but we're actually limited to 16 anyway because a turtle only has 16 inventory slots.
Cool. So if someone's going to add their own world to this, or add their own books to this, how do they do that?
Well, that would be quite simple. For example, if I wanted to add another one, it would be just this. Blah blah. Done.
Cool.
There's the same list in the turtle script, so you add the same text to that script, add a book, and you're done. Quite simple.
Okay, you don't have to worry about setting numbers or anything, that does it automatically, is it?
Calculates it all automatically.
Fantastic. So if you're going to steal the code and don't want to know how this works, then all you just do is go to the this destination list, add the destinations on the list as you can see on my screen in the center, and there, fire away. Put each book in each slot one at a time, with, you know, main tripod is the first destination in slot 1, 2, 3, 4 and 5. going down the list from 1, 2, 3, 4, 5, and then
It even has some code that will spread out the words over your monitor so it looks a bit decently. That not everything is in the top left corner.
So, as we said, there will be a link to a paste bin, so you can go grab this yourself. And cool. I'm just coming out of that screen for a moment. So I think that's probably the most basic that we can give like most users, and that's how this thing works. And I hope you like the idea of our Nexus. And this is going to end up being a short episode for most of you, I'd imagine. But if you're a programmer and you want to hang around, me and Malinka from here on in are going to go into very raw programming details and the rest of it, and very technical on exactly how this thing works. But if you're disappearing now, so thank you very much for watching, and we'll see you next time. If you're hanging around, we'll get stuck in. So thanks. Malinka, do you want to go into technical details now, and we'll go proper in?
Of course, of course. The biggest challenge for this computer setup actually is making sure that when you start up the both computers that they sync correctly and they can actually detect which portal is currently loaded, or no portal at all, which is also an option. So what we need to do is we need to start up and then sync. Let's see, we'll need to go down a bit. Here's our main block. We'll start there. The first thing we do is basically load the monitor. We set on what side it's found. We can set the color, and of course we clear out the screen from whatever crash we opened up last time. After that we open the modem, and I forgot two variables that I need to highlight here. For the modem I've got modem side, and for the monitor I've got monitor side. Both can be set completely at the top. I've put them in local variables there. That way you just have to open the script, immediately edit and close again. That way you don't have to look through the whole script where you have to change it.
Yeah.
Our main loop is quite simple. We draw a monitor, read the input. If it's a valid book, we send a signal. But to do all that, we need to synchronize the two computers, and that's what we do in this procedure, startup sync. So let's go look at that. Draw monitor, startup sync. Startup sync is actually quite simple, but at the same time complicated because it has some parallel programming. There's an API in Lua for Computercraft that's simply called parallel. With the procedure wait for any, we can use multiple procedures at the same time, and as soon as one of them finishes, it'll go back to this procedure, cancel the other one, and go back to whatever code follows after this line. In this case, I've got a loop on that. I'll come back to that loop. Let's see what startup sync does. Startup send sync is a bit topward. Right here. Startup send sync is quite simple. One broadcast that sends to the other computer, startup sync as text. After that it'll make the computer sleep for 10 seconds. Basically I just have a repetitive loop then, sending the broadcast startup sync, hoping that the other computer will pick it up and then send a signal back. 3 guesses what the other procedure is for then. Startup rec sync, where is my cursor? There it is. Is for receiving that signal. So if the turtle receives that startup sync, it'll send back a signal. In this case, we've got that loop going, which will read out a message back from RedNet. And if that message is of the text startup sync complete, we've actually got a link between the computers. We both know on which procedure they're busy. Which also means that we don't need a startup cycle anymore.
And if it doesn't sync up, does it just keep running it till it finds the sync?
Yep. That's the fun part about the startup send sync. That actually gets sent every 10 seconds. So it crashes the startup rec sync every 10 seconds and redo it. So as long as the turtle doesn't respond, we just keep up sending a signal every 10 seconds.
Okay.
Well, turtle sends a signal back. We close the startup loop. From that message also we get the current book for the highlighting on the monitor. And we are completely done with our startup. We know what the current book is, and we know that the turtle is ready to receive.
Cool.
So we'll go back to the main block. Startup sync is done. Time to see what we draw on the monitor. Let's see, draw monitor is over here.
Yep. I see it with the local X1, Y1.
Yep. Basically local X and Y is just for writing the text. In this case we'll set the monitor color again back to black, clear the line, and here's the bit of magic that I use to get the lines a bit spread out over the monitor instead of just the top left corner. I've got a local variable at the top which holds the current number of maximum lines on the screen. For a 3x3 monitor that's 19 lines. 6 on the top monitor, 7 middle and 6 on the bottom. So what I do is take that number, divide it by the number of elements or destinations in the list, round that down to a round number, and we'll know how many lines are available for every element in the list.
Okay.
Once we've done that, we start a small... sorry?
As you said, okay, go on.
Okay. Once we've done that, we'll have a small loop over the destinations to type them out. Basically, we start out at 1.1 for that X and Y. If the selected book is the one currently in the portal, we'll set our background color to blue, else we'll set it back to black. Write our destination. Increase our Y coordinate with the amount of spacing we've calculated, and we loop again till we've done every of our destinations.
Okay, I think I can keep up with that.
So once we've drawn the monitor, we just need to wait for an input. For that we've got our procedure read input. Back up a bit. This one is actually also quite simple. We've got a local boolean to see if we found an input. If not, we'll just keep on looping. First we've got to read out what position the monitor is being touched. For that we use an OS pull event of the type monitor touch. That'll give us some events back. In this case the event, the site that happens on, and the position that happens on. We do an extra confirmation that it's the right event, and if so, we'll start a bit of magic calculation to see if the location they pressed actually corresponds with one of the locations of the destinations. Once again, we set our Y coordinate to 1. Oh, sorry. Set our count to 1, as in the first position available, and we start looping. First we'll have a simple searching loop with a not found, not LV found, which will be set to true as soon as we find whatever destination is being clicked. And here's our second stop. What's the correct English term for that? Actually, I don't know. I think it's predicate.
Oh, okay.
The second predicate for our loop. In this case, as soon as Y is bigger than the amount of lines available on the monitor, we do need to stop the loop. It means that that they clicked somewhere that isn't a valid coordinate.
Okay.
So what we do is basically Y starts at 1, where the first destination is, and if that's the same as the position that they actually clicked, well, we found our book. If not, we just increase Y again with the amount of spacing we've calculated earlier, and increase the count by 1, as in we'll go for the next destination. This just keeps on looping through all the possible lines, and in the end, if we find the book, we'll have the number of the destination they've pressed. We can print it out to our logging, and I'm basically done with this loop.
We'll see else
If we,
new book equals
however,
-1 for dropping the count back down.
That's the fun part. If you click, for example, on a valid destination, say the main tripod,
Yeah.
but then click the second line after that, it would reset again, reset to that first one, because you don't, because you didn't, well, invalidate your local values. It's
Okay.
safer to reset your value than to just leave it at whatever value it was. So with our input, we've got a value in new book. The new book will contain the value for the coordinates where we have to go next. If new book is higher than 0, we've got a valid coordinate. So let's go see with send signal how that works. As you can see, send signal is very short. We just broadcast the new ID. Set the current ID for the new ID and reset the new book.
Okay.
And that's all this monitor actually does.
Can we go up top and have a look at your local variables? I think that's the right word. I'm not a programmer, so...
Yep, we can.
Because I think part
This
of it
you
was
mean?
skipped. Yeah, I think that was skipped pretty quick. So here we're saying that like the modem side, which you pointed out earlier, we're actually saying now, well, it's definitely on the right side. We know that we've said it there. The monitor side, we know that it's at the back of the machine. Didn't you come up with an issue with the where you put the monitor?
Sorry?
Didn't you come up with an issue that monitor side equals top? Didn't
Yeah.
work?
Yeah, for some reason the touchscreen events didn't really work as well when the monitor was on the top side. I have no idea why, but well, when you put it to the left, right or back, it doesn't seem to have that same problem.
Cool. Alright. Is that everything with the computer then? Do I need to switch locations to the turtle now? Once you've got
Yep.
it running again?
Basically, I can just type startup here, and that'll keep on waiting till I start up the turtle.
Oh, okay, cool. Right, let's come around to the turtle. Hello, Mr. Turtle. Alright, I got it.
Mr. Turtle. Mr. Turtle has basically most of the same values. We've got a modem side. We've got a redstone side. I've talked about that earlier. The redstone is where we output the redstone signal for the transposer. We've got a currently selected book. We've got an incoming value for the book. Max books is basically the amount of destinations available. That's used for some loops. I'll come back to that later. And here we've got the same list of destinations. Same as with the computer, just add one line and everything else is automated.
Yeah, making sure that you've got a book in each slot that corresponds to each location.
Yep. And of course, you don't have any empty slots between the books. You just need to fill up slot 1, 2, 3, 4 and so on.
Although, in this case, we've got slot 3 open because the Biodome book is actually in the machine right now.
Exactly. If you have more open slots, that'll actually confuse this program.
Mm-hmm.
Okay, we'll start out with our main block with initialization. First, we calculate how many destinations there are. It's quite simple. We've got a destination list, and with a table.getN, we receive the number of items in that list. We save that in the variable maxBooks.
Mm-hmm.
After that, we open the modem, and we'll see what current book is selected. So let's look at the procedure getCurrentBook. Startup sync. Get current book. Yep. Unfortunately, this screen isn't wide enough to show the whole line at once, so we'll have to scroll a bit to the left and right. But it's mostly the same as that other search loop that I had. A not LV found and an upper bound predicate for the loop. Basically what I do, I start with position 1 with that Y value here and see turtle.getItemCount Y is equal to 0. If that's true, we found this, the first empty position in the book, in the book list. So that means that book is currently in the portal.
Yep.
If true, set the current book to that value. set our selection in the turtle to that position as well. Well, and if it's not empty, we just increase for the next slot in the book list.
Okay.
Let's see. And here's what to do if y ends out as the value of the max books plus 1. In other words, nothing is in the portal. Then we just select the first book, nothing more.
Okay.
Once we've got the current book, we start our startup sync. Basically the same as the other side, only in reverse. Let's see, startup sync is
there it is.
over here.
Yeah.
The startup sync is actually really short. We've got a loop again that'll keep on waiting until it receives a signal. There, now we can see the whole code.
Yep. Do you want to?
And once we receive,
right. Yep.
yep. We've got a loop, and once we receive a signal through RedNet,
Yep.
we'll check if that message equals that startup sync that the other computer sends. If so, we can stop our waiting loop and send our current book ID. For that, I think we need to scroll up. Send current book ID. Yeah. The current book ID is a twofold message. It's actually a table. It contains two elements. One is that text line that confirms that it comes from the turtle computer. And the second is the book value. The current book again. We serialize that text so we can send it through RedNet. And then actually send it. Once that is done, it'll move from startup sync back to our main block and start up the receive signal.
Yep.
Let's take a quick look at receive signal then. And that is over here.
Yep.
Yep. As soon as someone uses the touchscreen and sends a valid book, we'll receive that here, transform that character into a real number, see if the value is a number or not with a nil check. I'll set it to -1 if it's a invalid input.
Yep.
Now we've got a check here in the main block. If that new book is between the values of 0 and whatever maximum number of books is available, we can set the book. Let's see where set book is. Right here. Once again, I've got a reminder in here that the turtle.suck doesn't work on a receptacle, so there's a workaround needed with the transposer. So
yes,
normally this whole block here with the redstone and all that, well, we could basically replace that with a turtle.suck and solve the whole problem. Unfortunately that doesn't work, so what we now do is select the current book and give an output to the redstone side that's true. In other words, activate the transposer. Sleep for 1 second, turn that redstone output off. By that time the book will actually be moved by the transposer in your pneumatic tube. And then we'll start waiting till it actually arrives.
Yep.
As you can see, I've got a turtle.item count here that waits until it's bigger than 0. Or that the current book is currently value -1, which means that no portal was in use yet. As soon as either of those two ring true, we stop our searching loop and are basically done with retrieving the book. Once we've retrieved the book, we can select a new one, drop it down into the receptacle, and make sure that the current book contains the value of the new book. After that, we print our destination, and are basically done with opening the portal.
Fantastic. Cool. And once you've got that started up, it will send its signal over to the monitor, and I believe it should reload itself and be running again. Like
Yep.
so.
Basically, as soon as you can see this text, means that both computers have synchronized, and that you can use it to travel wherever you want to go.
Yeah, so in our Valentine's Day episode, we did show using RedNet signals a little bit, so you know that you can wrap signals on the these modems on the side of turtles, like so. There's one there. Just if I can come down a block, there we go. There's one just here, and there's one on the side of the monitor as I just showed. Yeah, so hopefully you kept up with that. If you've got any questions, then leave in the comments, and probably either myself or Malinka more likely will come around and perhaps answer any questions that you might have about it. We'll help a little bit, although you know we don't. If you're a complete newbie to programming, I'll be honest. You know, trying to teach someone how to program is going to be too much to do in the comments of a YouTube video, and you should.
Oh, definitely.
But if it's a small question that you have, then feel free to ask in the comments section. That'd be great. Let us know what you think of the build. And as I say, we're going to have this on Pastebin. By the time this episode goes up, the Pastebin will be up as well. So that will be good, and we'll link it in the description below. Cool. Where should we finish off? We're going to the Biodome to finish the episode and to celebrate our victory.
Actually, then I'd say engine room, because I need to check the engines anyway.
Oh, okay. Cool. And through our... oh, by the way, we designed this room to be a little bit like Stargate. And these areas here are so that people can come with like bows and arrows, and if anything that comes through the portal shouldn't be here, we can like shoot them. If not bows and arrows, then we could always...
Whoa, 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 whoa!
I don't think he's wearing armor.
We had an intruder in the base. Okay, let's go.
I'm sorry, Igo, we didn't recognize you. You weren't wearing your green.
Yeah, he was. Oh, cool. And
It's okay. I was being a test dummy for the intruder reaction scenario.
Fantastic. So thanks for joining us on this episode of the Nexus. Again, leave us a comment. Hope you enjoyed it. And for those that stuck round to the end, good on you. I know there's a lot to learn there. But for me, Elfie, Aiko, and Malinka, who did an amazing job on the Nexus. We'll see you next time. Goodbye.
Goodbye.
Bye.
Farewell.